Hi, I think I'm up to my fourth video on section 9.1, and I just have a few loose details that I've got to tidy up. So I've put them all into one category. We have criteria that we need to meet. If we don't meet criteria, then I can't use this process. So what the heck is the criteria that I need to meet? And what the heck have I done with the criteria? Here we go. It's, first of all, sample needs to be SRS. Always, always, always. It's going to be that for the end of the quarter. Secondly, I need my situation to be binomial, because once it's binomial, I can approximate with the normal distribution and then be using that lovely picture that we were seeing in the first video. So if it's binomial, we get almost everything for free if we're talking about proportions, except we don't get independence for free. And in order to get independence, we need the sample size to be less than 5% of the population. So no surprises there, I'm hoping, yes? And number 3, I don't know if you remember this, in order to approximate binomial with the normal distribution, I need n times p times q to be greater than or equal to 10. Oh, hang on a second. Aren't I trying to find out what p is? Maybe I don't need that. What I actually need is n times p hat times q hat, which is going to be really close to this. So let's replace that with that. Need that to be greater than or equal to 10. So that's the criteria that I need to meet before I proceed with finding the confidence interval. So that's issue number 1. Issue number 2 is I want to talk a little bit more about what do I mean by 95% confidence. So I've thrown a definition up here. The confidence level is the confidence we have that our interval contains the true parameter. In section 9.1, we're talking about the confidence that we have that our interval contains the population proportion. And you might be thinking, why do I need a confidence level? Clearly, I want to be 100% confident. Well, I can be 100% confident. I am 100% confident that any proportion is between 0% and 100%. But that is the only way I'm going to be perfectly confident. And you might have noticed that's really unhelpful. How many people are voting for Trump in the next election? Somewhere between 0% and 100%. Thanks for helping there. Okay, so that's not good enough. So I have to accept something less than perfect confidence. Maybe I want 99.99% confidence, which will be quite a large confidence interval. But 100% confidence, that means in the world of probability, perfectly confident. And that's the only way I'm going to be 100% confident, is to say all proportions in the whole wide world. Then I'm pretty sure I've covered it. Okie dokie. So what does confidence have to do with your margin of error? How does the confidence level affect the margin of error? I could have typed that. Oh well. Oops, and that is a question there. In other words, if the confidence level gets bigger, if the CL is bigger, what happens to my margin of error? Well, let's have a look at this picture here. Hang on a second. So, I'm going to have you throw a sock at the screen. Okay, don't do that. That's gross. But anyway, imagine you were throwing something soft that won't hit the screen. Which one are you more confident of hitting? Which target are you more confident of hitting? The bigger the target, the more confidence you have. Likewise, the bigger the window, say I've got p hat here, if this is my margin of error, I don't have much wiggle room. Or I could have this be my margin of error. The bigger my margin of error, the more confident I am that it contains the parameter. Because there will be some small amount of time when maybe 95% of the time, the parameter is somewhere in here. But occasionally, there'll be some rare instances where the parameter is out here. But with that larger margin of error, I'm more likely to be containing the true parameter. Now let me sneak in one more idea here. I've told you that you can present the confidence interval in one of two ways. Your confidence interval can be written as the sample proportion plus or minus the margin of error. That's one way of looking at it. Or we could look at it as the sample proportion minus the margin of error and the sample proportion plus the margin of error. Now, but the question is, can we bop back and forth between the two? So suppose this is our margin of error. Suppose this is our confidence interval. Suppose the sample proportion that we've collected was 44% and the margin of error was 3%. Can you write that as an interval? So you need to see that this is the sample proportion and this is the margin of error. You need to be able to look at this and see that it's in this form. Oops, pressed a button. So that the first value here is your sample proportion, the second value there is the margin of error. And from there, then you go to the other form plus the margin of error and fill in the values. So this is 44% minus, so I'm going to erase that, minus 3% on up to 44% plus 3%. And so that gives us a confidence interval of 0.47 on up to, oh gosh, went the wrong way with that. This was supposed to be subtracting. 0.41 on up to 0.47. Arithmetic in my head, I will always mess that up. So that's how we go from a confidence interval in this form to a confidence interval in this form. Now let's go the other way. Oh heck. Sorry guys, I did that whole other screen with the video turned off, so I'm going to do that again. So we were talking about, this was the confidence interval we found in the video about margins of error, from the calculator video, where the true proportion of people who were worried about identity theft was somewhere between 0.499 and 0.561. I'm rounding from the values that we got there. And I want to put this in the form of, I want this to be in the form of p hat plus or minus the margin of error, but I'm looking at that and I'm not seeing the margin of error. So what I do know is on the number line here, I've got the sample proportion, and if I go down by the margin of error, I'm going to find myself at 0.499. And if I go up by the margin of error, I'm going to find myself at 0.561. So the distance from here to here is 2 margins of error apart. So if I find that distance, 0.561 minus 0.499, and that I have shoved into my calculator is 0.062, that's the distance from here to here, which is 2 margins of error. If I divide it by 2, first of all, I'm going to get 0.031, and secondly, I'm going to get what's the margin of error. So let's cough up a formula on how to find the margin of error. But while we're at it, let's also figure out what the heck our point estimate is. The point estimate is the middle of the lower limit and the upper limit. And I can find the middle between two values by averaging. So I can take the upper limit, add it to the lower limit, and divide by 2. And what I'm going to come up with is our point estimate after some rounding. Sorry about that. So let's find a formula for finding the margin of error and the point estimate if all you know is the confidence interval. Okay, so suppose we've got a confidence interval. And so that confidence interval, I'll just make it be a generic confidence interval. So the bottom end of the confidence interval I'm going to call the lower limit. And the upper end of the confidence interval I'm going to call the upper limit, which I'm going to abbreviate because that's a lot of writing. The lower limit and the upper limit. So how to find the margin of error if I only know these two values, but I know it's a confidence interval. I know that the margin of error is going to be the difference between the upper limit and the lower limit divided by 2. That's how I can generate the margin of error. So my calculator will find me this. I can get this from my calculator. Oopsie, pressed a button. Hang on. Get from my calculator and then with a fairly simple formula, I can cough up the margin of error. And with an almost as simple formula, well, it is exactly as simple, it's just where did it come from? It's not quite as simple. I can also get the point estimate. And in this scenario, the point estimate will be my sample proportion. So I can also regurgitate the sample proportion if I know the confidence interval. Okay, one more thing I want to talk about, which is the conclusion, or how we're going to interpret a confidence interval. Suppose I am 95% confident. I have a 95% confidence interval that the true proportion is somewhere between these two values, A and B. How do I interpret that math statement into English? This says that the fastest and easiest way of interpreting this back into English is we, or the researchers are, or I, we are 95% confident that the true proportion, or the population proportion, is between A and B. And the reason why I'm giving a fairly specific way of interpreting this is because this can be misinterpreted. Sometimes people might say that there's a 95% probability that the true proportion is somewhere between A and B, and that would not be accurate. Actually, we only had a 95% probability that the sample proportion was in a given window. And we definitely can't say that 95% of all sample proportions are in the confidence interval. The confidence interval actually only talks about the population proportion, and there's only one. So I want you to get the hang of this particular language for interpreting your confidence interval so that you don't get yourself into trouble. Okay, that's the end of this video.